So this is Biology Chapter 1.1 notes. Follow along with your note-taking guide. Okay, so what is science? Science is an organized way of gathering and analyzing evidence about the natural world. I should also say that on the classroom website, below this link, there are 2 links to videos that I'm going to reference in this video. So what I would do if I were you, when I get to that point in this video, pause this video and go watch that other video that I'm going to talk about, and then come back to this one. So you'll want to manage that. So this is the first video, the TED Ed. Scientists are creative. They think outside the box. They have to ask questions about the world around them, the natural world, to find out or discover new things. We'll see through this semester in biology that a lot of scientific discoveries isn't the result of one person, but many idea. And sometimes it takes a long time for all those pieces to come together to make a great discovery. Sometimes it happens by chance or a lot of the hard work of some other person. But so these are some attitudes that scientists need to have to be able to explore and discover. The first one being curiosity. Okay, do that. Okay, so we're still going. I just want to make sure we're still going, because last time I filmed this, it stopped at me. So curiosity. And hopefully you saw that in the video that you hopefully watched. I could spell it right. That would be cool. Curiosity. Scientists need to be curious. Why is it that way? Why does something do this? Why do I always get sick in the spring with like this upper respiratory thing? What could that mean? They also need to be open-minded. Mindedness.
Emma El-Rafa, please come to the office. Emma El-Rafa, thank you.
A little interruption. New ideas. Science has changed over time. Okay, people used to believe the Earth was flat. Okay, you need to be open-minded to possible new ideas. Creative, like I said right away. To be a scientist, you need to be creative. Think outside the box in new and different ways. And you need to be a skeptic sometimes. I'm going to show you a link, if I can do it here. Hold on. This is a website I want to show you. Read about dihydrogen monoxide research division. It's all about this chemical that has it's dangerous. It causes cancer. Look at all these things it causes. A causative link between dihydrogen monoxide and evidence suggests that it plays a role in formation of cancer. All those type of cancers. And it says it's not believed carcinogenic, although it's known to be a component of a number of cancer-causing agents. So this is a whole website devoted to the danger of this DHMO. Well, guess what DHMO is? It's water. So that is an example of a website that's meant to show you that you shouldn't trust everything you hear all the time. Okay? If you read something on the interweb and you think, that doesn't sound legit, maybe look into it. Don't trust everything you hear right away. Be a skeptic sometimes. That's what scientists have to do. Why do scientists conduct investigations? Hold on one second. So why might a scientist decide to research something? I know when I look into things or I want to discover, maybe it's discovering a new species that has never been discovered before. Maybe it's just discovering something about health or fitness or something that you are interested in. To explain the world around them, or natural phenomena, or observed. Okay? Why does it do that? Let's research to why this happens, okay? Let's study it. Let's make a hypothesis and collect some data to figure out why this phenomena that I'm observing is happening. To test conclusions of prior investigations. Let's look at this work this scientist was working on with penicillin. Look what he found. Look at his notes. Let's try to make this into a drug that can help people take care of bacteria. Testing a prior investigation. We'll talk about that discovery. To test predictions of current theories. There was a theory that autism was caused by vaccinations. Is that true? Can we test it? So those 4 things are 4 reasons why scientists conduct investigations: discovery, explain, to test prior investigations, conclusions, and to test current theories. So now this is the second video. I only want you to watch the first 4 minutes. It's about a girl and her research done for a science fair. It's a national science fair. She's in middle school. She does a great job talking about grilled chicken. So pause it and watch that first 4 minutes. Okay, so the first step of the scientific method is observations. Simply looking around you and seeing what you see. She noticed something in her doctor's office, how this chicken was dangerous, okay? So she noticed that. In this picture, look at the grass. This is in your textbook as well. Look at that grass is so much taller than the other grass that are in a similar location. Why is that? That's the first step. The second step of the scientific method, inferring and or hypothesizing. We believe if more nitrogen is added to this plot of land, then the grass will grow taller. That is a hypothesis. A hypothesis has to be testable. After the hypothesis, you have to set up an experiment. And this is where you collect your data. In any experiment, it needs to be controlled, meaning you only want to test one variable at a time. So here they're testing whether nitrogen causes the grass to grow taller. They have a control group, meaning a plot of grass or land, soil that they didn't add any nitrogen to, called the control group. And then they have the experimental group, where they added the nitrogen, that element, to the soil. Okay? That's a controlled experiment. So that at the end of your experiment, you can say, yes, nitrogen made the grass grow taller, or no. Okay? At the end. The fourth step is collecting that data, putting it together, and analyzing it. So data can be qualitative or quantitative. Quantitative, you think of quantity, this is numbers. So measuring the height of something or the weight of something would be qualitative data. Quantitative. Qualitative would be not numbers. The grass is a bright color of green, or it's very thick, or it's very thin, or the grass is brownish. Those are qualitative. How does it look? It doesn't have anything to do with numbers. And then analyzing the data, you also can make graphs or tables to show what your data looks like. And that is important and something that we will practice. And then when you look at those tables or graphs, here we have a graph of that data collected. The time in weeks, this is where you put your independent variable on the x-axis. This is the time in weeks. This is what you choose or what you decide. I'm going to test every week for 18 weeks or whatever it is. I'm going to measure the height. The dependent goes on the y-axis. You don't have control over that. Okay, this is what you're measuring, and this is the height. So we can see from this graph that this is the control plot, and this is the plot that nitrogen was added, that when you add nitrogen to the soil, the grass grows taller. Time over time, and then height of the grass. And then at the end, when you draw a conclusion, your hypothesis will either be accepted, yes, nitrogen does make grass grow taller, or it's rejected. The nitrogen has no effect on the height of the soil. And that is where we're going to end this video.